guys all for coming. This is Intermediate OOP and PHP. I'm Dave Stockton. Thank you for all of you who came yesterday and decided to come back again for today's thing. I hope you'll get some good information out of it. We've got a whole lot of things to cover, but if you have any questions, just raise your hand and I'd be happy to answer them at any point in time. Some of the things we're going to cover would be magic methods, polymorphism, collections, filtering collections, the SPL Iterator. We're also going to cover SPL count, SPL ArrayAccess, the listener pattern, what loose coupling means, and what high cohesion means. So this is a significantly higher talk than yesterday. This is more for people who have been doing OOP for a little bit, or if you came yesterday, hopefully you'll get enough out of this that'll be worth it for you. The first thing we want to do is cover magic methods. So these are, there's my keynote crashing. I apologize again.
Quick question.
Yes, sir.
Be available to us?
Yeah, actually I did. The slides are already online for yesterday's talk and today's talk. It took significantly longer to get them online than I thought it would have. So I just did them all at once. So all of my talks for this entire conference are online at this point. And you can go to the joined in link, which will be at the end of the talk, to find the link to them. But they're going to be on SlideShare. It'd be slideshare.net/dstockto, and then I don't remember what the rest of it is because I've had a couple of talks that I uploaded for intermediate OOP and PHP, so they throw some kind of numbers and dashes and things to make it unique. All right, let's see if this will work again. Hopefully it will stop crashing. So we're going to cover magic methods. Magic methods are special methods within PHP. All of them start with a double underscore, and PHP says don't make your own methods start with a double underscore because they could come up with one and it will clobber yours and then your code won't work. So the first one is the construct method. Construct is used when you new up an object, when you create a new instance of an object. What you want to do in the constructor is you want to initialize properties. You want to pass in variables and set them. You don't want to do work. We did cover this a little bit yesterday, but it's something you definitely want to avoid in a constructor. I do have examples later on with code that does do work in there to make the code shorter, but in real code I would definitely not do that. Destruct, or underscore destruct, is called when the object goes out of scope. So when there's no longer anything that knows how to get to that object. So if you don't have any variables pointing to it or nothing pointing to those variables, it will be called, and you can do things like shutting down database connections or other sorts of cleanup work there. Construct is very, very common. Destruct is significantly less common. Any questions on those two? Okay. The next magic method is underscore call, and the signature looks like that. You have a name, which is essentially the function that's going to be called, and then you have an array of arguments. So this is called when you try to make a function call, or a method call rather, and that thing doesn't exist or it's not in the scope in which you are. And what I mean by that is if you're outside of the object, right? So you make a call to a function that doesn't exist or is not public, it will call the magic call method, right? And it will pass in the function name that you used, and it will pass in the array of arguments that you pass through to that function. So you can make it do other things. You can essentially have unlimited functions that are made up and used at runtime, right? ORMs do this sort of thing a whole lot. So you'll have find by whatever. They didn't make a find by whatever you happen to call your database column. They have a magic method that says, okay, we're going to take this part of the method, and I've got an example here in just a second. The part I do want to go over, though, is like how this is called, because it's not completely clear most of the time when people see it. So it's not just that it doesn't exist, it's that it's not in the scope in which you are, right? Or in which you're in. There's the preposition. So when you make a call, let's say you're inside of the method, or inside of the class, the object, and you make a call. Inside of a class, if that method doesn't exist, magic underscore call will get called. If you're outside of that and that method does exist, but it's set to private or protected, magic call will be called, even though that method may exist on that object. Does that make sense? All right. So here's an example. We've got a class foo with a magic call. It's taking name and args, and I'm doing a regular expression match to say that if this thing matches, if this function name matches find by something, then I'm going to call find by field with the value of whatever the field part is, so whatever came after find by, and then I'm going to pass in all the rest of the stuff, or I'm going to pass in the first argument, right? So the bottom part here is how we would actually call it. We're going to new up foo, and then we're going to go find by samiflange. And it's going to pass what's a samiflange, or it's going to pass in samiflange for field into find by field right here, and it's going to pass in what's a samiflange to value right there. Okay? Does that make sense? So imagine if you are making calls where, again, like the ORM example, you have a field that you, as a developer, wouldn't necessarily know exists, right? The framework developers don't know what fields are in your database, or the ORM developers don't. But they can make a function like this that will say, okay, well, we know what a SQL call looks like that's going to find a certain thing in a particular column, so we can give you helper functions that look like this. So I think I've got more examples on this in a bit, so I'm going to go on to the next one. Any questions on that? Okay. Call static is the next magic method, and it is very, very similar to how call works, but it's for static methods. So if you make a call with : whatever, and it doesn't exist, call static will be called. It hasn't been around forever. I think it was introduced in, I want to say 5.4, but everybody ought to be on 5.4 or later at this point. 5.3 is well out of support. Is anybody still on 5.3 or older? Nope. That's good. Should also move to 5.5 and off of 5.4 or 5.6, because 7's coming out soon and 5.4 will be going away fast. All right. Next we've got get, IsSet, or get, set, IsSet, and unset. And these all kind of go together. If you need to build one of them, you probably are going to want to build all of them, or you can run into some weird issues. So we'll go through each one of them in turn. We've got magic_get, and this is called when you're reading a value for a property on an object, and that property is not in the scope of what you're doing. So same kind of explanation for call, right? If you are in public scope, if you're outside of that object and you call magic_get on a property that isn't public or doesn't exist, this will be invoked. Yeah?
Are all these like 5.4 and above?
No, most of these have been around since I want to say 5.0 or 5.2. They've been around for quite some time. There's a couple at the very end that are newer, like in the 5.4, 5.5, 5.6 kind of range. But so far everything has been, as long as you're on 5 dot something, you'll have it. So if we call, if we set value equal to foo made up value, right, this thing that doesn't exist, magic_get method will be called, and we can set something here. So this is what those look like. We've got a set of values, and if we put things in, imagine values as an array inside of this object, right? And so we can just do our arrow operator and whatever, and we'll pull the value out of the array using that name for the key. Does this make sense? So here's magic_set, and set, same explanation. Set is going to be called when you are trying to set the value onto a property that is not in scope. So it either doesn't exist at all, or you're outside of the scope of where it is. You're outside of the object and the property is there, but it's set to private or protected. And this would be an example of how we could use that same class with the values and set things onto it without polluting our public names or our public area of the class, right? So everybody know, like, when you're working with an object and you put something on it, if you don't have this set, it will make a brand new public property on your object just automatically. Has anybody done that? Like, if you haven't defined it as being private or protected, you haven't defined it at all, for instance, and you go and you set a new variable, it will just throw it right on the object, and it will be public.
You're talking about the instance.
Yes.
You do that with the instance of the class.
Yeah, so here would be an example, right? So if we say, let's say bar doesn't exist. So we say foo bar and we set it to Baz, right? So it's going to call the magic_set function. The name right here is going to be bar. The value is going to be Baz. But we're going to stick it inside of that values array, which is protected, right? So you wouldn't be able to get to it normally. If you don't have this set function at all, PHP is going to make a brand new public property called bar with a value of baz on that object, even though you haven't defined it anywhere. That's just what it does. Okay? So you can use magic set to prevent that sort of behavior if you want. If you don't want people to be able to set things at all, but you don't, like, you could just throw an exception as the only thing you did in your set, magic setter, and it would prevent you from being able to set non-defined properties. Right? So here's why we need them all, and I know I haven't covered the last two, but if we go and we say, all right, we've got our setter, right? So our magic set gets called here. So now inside of our values, we've got this baz value set on a key of bar, right? And then we go and get it, and we get back baz, right? So now value has baz. Everything is working fine. But if we then go and say, okay, if it's set, right? And it should be set because this worked. We got a value back, but we will never get there, right? Because we're outside of the scope where this thing is defined, and we haven't yet defined that magic isSet. So this is why you need all of them. And so isSet looks like this. It takes a name just like most of the rest of them, and it gets called, again, when you try and call isSet on a property that is outside of the scope of wherever you're at. So isSet, for our example, would look something like this. It would go and check to see if that value has been set in the array of values that we have inside of our object. Does that make sense? If you don't do that, you'll get really weird bugs where you think this should totally go in because every time I look and I get the value, I get a value back and it's telling me it's not set. Unset is kind of the other side of that. You don't necessarily need it, but if you want to get rid of the value, you call unset on it. Unset will be called when it's not in the scope, just like everything else. And so this would be an example with the same exact stuff we've got going on so far. Make sense? So there's a bunch of different things that we can do with those. Like I said, we can make a class where we don't have dynamic properties. By default, you do have dynamic properties that you can just chunk onto an object. You could have a class that only allows you to set any kind of dynamic things, but only with certain naming conventions, right? Maybe we only want variables that start with the word user to be able to be set. We could make logic that does that. So we know all the user variables have user in them. Or maybe you can do anything, right? It's whatever you want to do, but those are some examples. If you have getters and setters defined in your object, you could automatically call your getters and setters, but allow the user or the consumer of your class to not have to make a function call directly. They would just use the property, and you would call your getters and setters. Make sense? All right. So there are downsides to these magic methods. The first one is that it's harder to follow. If you use an IDE, who uses an IDE? PHP Storm? No? What are you guys using? Notepad, TextEdit? What? Sublime? Atom? Vim? Yeah. So a lot of the IDEs will allow you to control click on a method or a function, and it'll jump to the definition of that. If the function doesn't exist, you can't do that, right? So that's a downside for like the magic call. So you don't get any of the autocomplete things that you would normally get with your normally defined functions, where you can just start typing a little bit and it'll fill in the rest of it. However, you can help your IDE out by using an @method doc block, and those look like this. So, excuse me, inside of my foo class from the very beginning, if I add this to the top of the doc block, my IDE will pick that up and it will autocomplete, or it will suggest like, hey, did you mean one of these? Even though I haven't actually defined either one of those methods, the IDE is smart enough to figure it out and say, these are probably something that you might want. Make sense?
Doesn't PHP Storm automatically do that for you?
If you put these methods in, it does. If you don't put them in there, it has no way to know, because it's an infinite number of possible function names, right?
Well, I'm surprised you can just go through the methods of the class.
It doesn't have the methods of the class, right? Magic __ call is what's going to be called if that function doesn't exist, right? So you haven't defined it anywhere.
You're still in magic, okay.
Yep. Yeah, we've still got a bit more magic methods. But yeah, so if you define them this way, then your IDE can be smart enough to autocomplete and give you some suggestions on what might be something that you want. All right. Any questions on that before we move on? All right. Next two are sleep and wake up. These are used not all that often. Sleep is used when serialize is called, and wake up is called when unserialized is called. So when you sleep, or when you serialize an object, there's certain things that can't be serialized, right? You can't serialize callables, so like closures, dynamically defined functions. You can't serialize database connections. If you try to serialize an object that contains one of those things, you're going to get an error. So in your sleep method, you can go and say, let's get rid of those things out of this object, and then we can serialize the rest. And then on your wake up, you can reestablish those connections and put the things back together. So now you have a fully working object again. All right. Next is ToString. This is called whenever you are using an object in the context where a string would be used. So it's automatically called if you cast your object to a string, if you concatenate it with a string, those sorts of things. And it allows you to come up with your own representation of a string version of that class, right? Let's take a look at this. So we've got an object, let's say it's a person. We've got a constructor with a first name, a last name, and an optional middle name. It just sets those values in, right? We're not doing any work, we're just setting values. And then we've got this public ToString method at the bottom that's going to put together a name that represents this object, right? So we could just echo out this object and ToString would happen. ToString would get called and it would go through this logic to figure out how to put the name together in a way that makes sense, right? So if we were using this, we can build a couple of people. We've got one person with a middle name, we've got one person without a middle name. And when we just echo out that object, it runs through that logic to put it together in a way that makes sense, right? So even though we've got a full middle name, our ToString here says take the middle name, turn it into initial, add a period if there's a middle name. But we don't want a period there if there's no middle name, right? So that's what you would get with that sort of thing. It's kind of neat. That one's used pretty commonly. Any questions on that one? And I don't know that I said, oh yeah. Cannot throw an exception. If you throw an exception or you call something that throws an exception in ToString, you're going to have a bad time. So make sure that your code either handles any exceptions that could happen or can't throw an exception in there. Yeah.
So, okay, sorry.
Okay. The next one is magic clone. And magic clone is used to build a new object based on an existing object. Okay, so we've already got a copy that we want. We want to make a new one. We use it like this. We say foo equals clone bar, and it will make a brand new object. All of the things inside of it will still be the same. Okay, so let's see what that looks like. This is how you would define, let's say, just two classes, right? We've got a foo class and a bar class, and we want to make our new foo class, and I am doing, this is my bad example, don't make code like this with new inside of your constructor, but we're making a foo with a bar inside of it, okay? And then we're going to clone foo to foo2. So here's what it looks like graphically. We go and we create our new foo class, which the constructor then creates the bar class, and it points off, yeah, there we go. It points off to it right there, right? So that's what our object graph kind of looks like. We have a foo, it contains a bar that points to a bar object. Then we call clone, okay? Both of our clones have the same exact bar inside of them. That's what I mean by shallow. It didn't make a clone of the inside objects. It just made a clone of the outside basic stuff. All of them still point in there. So this is where we want to use magic clone. So if we add this clone method into our class, we say, okay, whenever you get called, whenever clone gets called, we're also going to clone the inside stuff. So now we're making it a deep clone, right? A deep copy. And if we run that same exact code again, we instantiate our foo object. Foo instantiates our bar object and points it to it. And then when we call clone, at this point, the magic clone method is called, right? And so it's going to take that, make a brand new bar, and point it over there. So now we've got two sets of bar objects and two sets of foo objects instead of two bars, or sorry, two foos both pointing to the same bar.
Why would you want to do that?
A number of reasons, right? So objects in PHP are dealt with by reference, right? So if you cloned an object that contains another object, but you didn't clone the inside object, but then you changed it, it's now different for both of them, right? It's still pointing to the exact same thing, right? So imagine you made a person who contains an address object, right? You clone that one. They both point to the same exact address object, and then you change it. You change the address for the first person. You've now changed where the second person lives also, because it's not unique to that person anymore. Does that make sense? If we do a deep copy like this, then each one of them has their own address that belongs to one or the other. And so when you change their address, you change only for that one individual. Make sense?
Yeah.
All right. Any questions on this part?
That's, yeah. Foo-2 at the bottom left? Is that what
Yeah, you're probably right. We'll say that says foo2. Yep. I missed it on that one. Yep, should definitely be foo2, like at the top. All right, so next is Magic Invoke. This is a newer one. I want to say 5.4, but I'm not positive. The docs will tell you which. But it allows you to treat an object as though it's a function or a callable, right? So this is pretty powerful. You can build up an object. You can configure a whole bunch of stuff, and then you can pass it into something that accepts an object, or you can call that object just like it's a function. So instead of having, say, loads and loads of parameters on a function, you can build an object, configure that object, and then use it. Right? So here's how this could look. So we've got an adder function, or an adder class. When we construct it, we give it a number, and then when we run it, it's going to take that number and add it to whatever the parameter is that's passed in. Okay? So what this would look like is we say, all right, here's this new object. We're going to call it add5, and we're going to create a new adder with passing in 5 to it. Now we can use that object as a function, pass in a parameter to it, and now anything we pass in to add5 gets 5, or will have 5 added to it, right? So add5, this object will add 5 to anything we pass through, right? So at this level, it doesn't sound very powerful. It's extremely powerful when you get into it. This is the very beginning, kind of scratching the surface of what's available there. But it allows you to do things called functional programming and a bunch of other stuff that's really, really awesome. Any questions on that one? Okay. Next is Autoload. This is a function, not a method, and it's been around for quite some time. But I would recommend you don't use it. There's a new function called SPL Autoload Register, and it allows you to autoload your classes and have multiple autoloaders. If you just define the underscore autoload, you can only define a single one. So it's not that useful anymore when you've got SPL Autoload Register. Does anybody not know about autoloading? So autoloading is pretty awesome, right? If you probably right now, at the top of your script, you've got a bunch of include once or require once, right? Autoload allows you to define a function that says, how do I find where this class is defined? And it will call it right at the moment that it needs to. If you new up a class or you new up an object, it will say, okay, call this autoload because I don't know where that class is defined. It'll go through, load the file that you want right at the moment it needs it, so you never have to put any of those includes or requires in your script anymore. It's awesome.
So,
yeah.
I'm waiting for you to say Composer. This is what Composer autoloading is all about.
Composer does do autoloads for you. You don't have to have Composer to do autoloading.
No, but I'm just saying it's a good segue into Composer.
It is, but I don't have anything about Composer in this talk.
Oh, okay.
But if you're not using Composer, that's also a good thing to use. It's great. Yes?
So is this a new way to conditionally load code or to avoid loading code that you don't?
Absolutely. Yeah, if you've got a big long script and it's got, say, a bunch of branching that goes on, and in one branch you load foos and in the other branch you load bars, normally you would have to go and require foo and require bar and do all that. In this case, it will only load it if it actually tries to create the thing. Yeah, it makes your code more efficient. Your code will tend to run faster if you use an autoloader than if you don't. You're not loading and compiling all of the stuff you don't need. So autoloaders are great. All right, next one. This is set state. I'm trying to think if I've ever seen this used in the wild. I can't think of anything. But it's used with var export. So if you've used var export as opposed to var dump, var export actually outputs PHP code that can be used to create an object itself. Set state can take the input from that and build out your object. That's all I got to say about that one. The next one is a new one in PHP 5.6, and it's magic debug info, and it controls the output of var dump. So let's say we have a class with a public value and a secret value, and we construct it and we put in some public data and we put in some secret password data into our secret area. When we var dump this thing, this is what we see. We see public data and we see the values of all the secret stuff, right? That's not necessarily ideal. If we then go and put in our debug info magic method, we can return, or we can control what is returned by var dump, or what is output by var dump. So if we don't want people to see what's in the secret value, we can mask it out or hide it or whatever else. And so now if we var dump that same object, this is what it looks like. So we've now hidden that data. The data's in the object. It didn't change anything, but you don't have to see it, or you won't see it if you do a var dump on it, which is pretty cool. That's all the magic methods. We're going to go on to the next topic, unless you guys have any questions on this. All right. The next one is called polymorphism. All right. This is a very powerful bit of object-oriented technology that allows you to use a code or different objects in the same way without necessarily having to know anything about the object. So yesterday we talked about interfaces. We defined a bunch of interfaces. This is another interface. We've got this speakable, and it says that if you are speakable, then you have a function on you called speak. So we could have a bunch of different objects or classes defined that implement speakable. We have a cat and a dog and a distinguished gentleman. We can make new instances of all of these things and put them in an array and loop over that array and know that we can call speak on them. But they're going to all do a different thing, right? The cat will do a different kind of speak than the dog, and the dog will do a different kind of speak than the distinguished gentleman. Does that make sense? Polymorphism is awesome. Next is collections and polymorphism. So we're going to switch off of cats and dogs and distinguished gentlemen. We're going to go to silverware drawers. So we've got a class called a drawer, and it will implement this interface called silverware container. It's going to have a couple of methods in there for adding utensils. I've type hinted everything, so you can only put silverware in the silverware drawer. You can't put all of the junk and coupons and everything else that might go in a silverware drawer, but probably shouldn't. And then on the get utensil, we've got a type hint for a thing called a silverware filter, which we'll cover in a bit. Here's what our interface looks like. And it just defines that we have to have an add utensil and a get utensil. As long as we've defined those things, we can call this thing a silverware container. Right? Could be a bucket. It doesn't matter. As long as it has add utensil and get utensil and implements this interface, it can be a silverware container, and we can use it in place of anything that needs a silverware container. Here's our interface for silverware. We've got 3 methods on there: isClean, getType, and useIt. And they will each do different things. But those are the things that silverware has to be able to do. So yesterday also we covered abstract classes. This is a utensil. You wouldn't be able to create this class on its own, but you could use it as a base for building specific types of silverware. So we've got a constructor that's going to accept our dirty and the type of thing it is. We've got an isClean that's going to return the opposite of the dirty value of the silverware. And we've got a getType that tells us what kind of a type this thing is. Okay? Does this make sense so far? All right. So now we've got a fork. This is a specific concrete class, not as opposed to an abstract class. We can instantiate this fork. Our user does something else I'm not defining in here. It does stabby stab sorts of things. And when we call stabby stab, which is defined within our fork, it makes the fork dirty. Right? Use the fork, it's dirty. Let's define a spoon. So we've got a spoon. When we use it, it turns dirty. And then we also define a new function that nothing else has called lickitClean or lickClean, and it will set dirty back to false. Okay? Now we've got a knife. The knife does slicey things, and when you use it, it also gets dirty. And we can clean it off by wiping it on our pants. Okay? Now there's different functionality in each of these beyond just use it, right? Wipe on pants is only defined with knife, and lickitClean is only defined with spoon. Stabby stab was only defined as a protected method within fork. So they're all implemented in slightly different ways, but they still are utensils, which means they all extend, or they all implement the silverware interface. So they're all usable in anything that asks for silverware. Okay? So we're going to put all the silverware away. So we instantiate a new fork, and we say this is a 3-tine fork, which I guess would be a threek. we have a butter knife, and we have a spoon. All right? Then we're going to use the spoon. So we've now made the spoon dirty, and we're putting it away. So we're probably not going to be allowed to put silverware away anymore because we're putting the dirty stuff in the drawer. But we'll take care of that here in just a moment. So we add all these utensils into the drawer by using the add utensil method, which took a silverware, right? So now we need to figure out some things. How many utensils do we have in this drawer? So we could add a new method into our drawer called getNumberOfUtensils that would go and count the things that are in our silverware drawer. Or we can do what we're going to do in this presentation, which is implement SPL Countable, which is an interface that is provided by the SPL, the standard PHP library, and it's pretty cool. So this is how we would use it. We add another thing that we implement up at the top, Countable, and Countable defines one method, count, and there's the body of count. We just return a count of however many items are in the silverware drawer. So this is kind of neat. We just use it by calling count on the drawer. We don't have to call a method on the drawer. We just count the drawer, and the drawer says, I've got 3 things in it, or whatever it may be, which is pretty cool. Any questions on that?
Wait, go back. So how does it know by you adding countable to use the count function?
Countable defines the fact that this object has count on it.
But the function had to be called count.
Yes.
Okay.
Count is what's defined in the interface Countable, and Countable is an interface that we didn't define. PHP defines it in the SPL. So it says if you've got this on there, and if you didn't define count, PHP will tell you you haven't finished your code. Go back and add count. You'll get a fatal error if you don't have it.
I didn't know if count was required.
Count is absolutely required if you put Countable on it. Yep. All right, so we can now count the drawer. So let's say now we want to retrieve specific utensils, right? I'm going to set the table, I need to get a fork out, or I need a knife, or I need a spoon, or whatever. So I could go and build a function like this and say, let's get an item at a specific index, right? Because we're storing all these things in arrays, so they have indexes 0, 1, 2, and so on. And we could pass in what numbered thing we want to grab out, right? We'd have to know where it is. We'd have to know that the fork is the first thing or the second thing or whatever, right? And know the numbers, so that's not super convenient. So we've got SPL. And SPL has something called ArrayAccess, and this is another interface that's provided, and it allows us to use our object as though it's an array. So it's pretty cool. It defines 4 different methods. So we're adding that on. We're saying, all right, it also, in addition to being countable, it also implements ArrayAccess. Yes?
What is this?
It's a standard PHP library. And there's a lot more to it than what I'm going to cover. It's pretty big, and it's also fairly not well known. So it's got a lot of good stuff in there. So in order to implement our ArrayAccess and be able to use our object as an array, we have to implement 4 methods. The first one is offsetExists, and this is essentially the IsSet. It's like, hey, if you ask for something at this spot, does it have a thing at this spot? OffsetUnset is removing a thing from a particular spot, and so these should look pretty familiar. They're very, very close to what we had in the Magic IsSet and Magic Unset. The other 2 are OffsetGet and OffsetSet. And OffsetGet rather gets an offset, right? It gets our array index, whatever you're using to access it, and it's going to see, does it have it, and if it has it, return it, otherwise we'll get back a false. And our OffsetSet will say, hey, if you didn't provide, this part is a little bit weird. This essentially allows us to use the empty array brackets, right, to add something to the drawer without knowing exactly where we're going to put it. We're saying stick it at the end, right? You guys know about adding things to the end of the array using square brackets, right? This, if we don't do that null thing, it'll actually add something at an index of null, and then next time you do it, it'll replace that one. So this one says if you didn't pass it in, if you got null for the offset, then we want to add it to the array, not set something at a null index. Yeah.
So if on the outside you use that notation with the square bracket,
Yep.
nothing in it, it will call this function?
Yep, and you'll end up in this part of the loop, or this part of the if. If you just put this in, then that first one will come in and offset will be null, and it'll actually put something in an index that's null. And the next time it will come in and it will put the next thing in that same exact spot, so you'll replace it. All right, so that allows us to do things like this. We can get a utensil out by making our utensil drawer look like an array. We can put things into it, and that's kind of exactly what you were talking about a second ago. We just put in the empty arrays, and it goes and sticks it at the end of the drawer, right? So that's pretty cool. Any questions on that part? All right. So next one we're going to talk about is using an iterator, and we will come back to the silverware drawer in just a minute. Usually when you want to implement an iterator, you will extend or implement certain interfaces or classes, right? There are a ton of iterator classes in PHP's SPL. There is the append iterator, which allows you to iterate over a bunch of iterators one after another. There's the array iterator, which iterates, anybody guess? It's an array. There is a caching iterator, which allows you to, once you've iterated over a piece, it will cache that value, and you can then use it for whatever you want. You can do a callback filter iterator, which allows you to call a function at each point while you're moving over the values of a iterator. There's an infinite iterator, which will start over at the beginning again once you've gotten to the end. So you could set up an iterator for like days of the week, right? And tell it, I want to see what the next 700 days of the week are, right? And it will go over your list of 7 over and over and over until it runs out of your outside loop, right? It's pretty cool. There's a lot more iterators than this. There's even iterators. And anyway. So we've got an easy way we can extend array iterator, right? So we've got our class definition. We say extends array iterator. Inside of our constructor, we put our items into this array object. We can now add some silverware. We can do all the array stuff. And now we can loop over these values in our drawer by using a for each. And we can have it echo out. So in this case, I've added a ToString method to each one of my utensils so they can say what they were when they come out. Otherwise, we would be echoing an object, right? So without the ToString, you wouldn't have anything printed out. So let's make a new iterator. We have a clean filtering iterator that's going to extend something called filter iterator. Filter iterator defines a single method called accept, and it says, what do we allow? And in this case, we're going to call the isClean method of the utensil, because we know it has it. It was part of our interface. And if it's clean, we'll return it, right? So now we don't have to worry about somebody putting dirty stuff into our silverware drawer, as long as when we call getUtensil, or whatever the thing was called, we pass in our clean filter. It will only get out clean stuff. So we run it over the same exact code, and look here, this is the earlier one. We've got our dirty camping fork, right? We used it and stuck it away. When we go and we say run, build this clean filter, and then loop over it, we end up with just our clean stuff coming back out. So it excluded out that dirty camping fork. Even though it's still in the drawer, we didn't get it out of the drawer. It's pretty awesome. It's very, very powerful. That make sense? All right. The next one is the SPL Subject and SPL Observer. So let's say we have an emailing class, right? And it implements this thing called SPL Subject. And on the next slide, I'll have the things that actually defines. But we have an email sender. It's going to validate an email, and then it's going to do whatever it is that it needs to do in order to send that email, right? All of that, not important for the example. This part is. This is what you need to implement SPL Subject, right? So we have an attach, and we have a detach. And what this is allowing us to do is have a bunch of stuff that's interested in whatever we're doing that our class doesn't have to know about. So it's going to tell these things, hey, I did a thing that you want to know about. We don't have to know anything about those, right? They're essentially telling our emailer, they're telling our emailer, hey, I'm interested in what you're doing, and I may have something to say about it, right? So we now have notify, right? So notify is one other part that we have to have, and it says when this gets called, we're going to loop over the observers, and we're going to call this update thing on them. Our observers are all going to implement something called SPL Observer. So we know how to talk to them, but that's it. We don't even know what they are. right? We don't have to know what they are. All we know is they have an update method. Are you raising your hand? Okay. All right, so let's say we have in our validate function, we get this email address, we do our validation. Once we've done our validation, we call notify, right? So notify is going to go over all of the things that have said that they are interested in our emailing class, and they're going to do something, right? So let's say we have an observer on there called an invalid email observer, right? And if the email isn't valid, it's going to disable the ability to send, right? So our emailing class didn't have to do that. We have something else that does that. So imagine, like how many people have done email sending through PHP or through code at all, right? How did you test it? Right? How did you test it in a way where you felt safe that you weren't going to accidentally email all of your customers, right? There's a number of ways you can do this, but it's always a concern, right? If you are, some of the other talks have talked about, like, let's copy down the production database. If you're testing your code and you go across to your production database and you send out this test email to everybody in your database, that's probably not good. Phil Sturgeon's talk yesterday talked about actually somebody doing this, and it lost them hundreds of thousands of dollars because all of their investors bailed, right? Because they sent out a root email unintentionally, right? So we can use this and add another observer to our email class that can limit who we send to, right? We don't have to modify our email class to have a test mode or a development mode or anything like that. We can have this observer tacked on there and says, okay, here's our observer. It has a list of email domains that all belong to us, hopefully. And before it gets sent, we're going to check and make sure that the emails belong to these domains that we're allowed to send to. And if it doesn't, we disable sending, right? So you can put this on in a development environment and prevent all of those real customer emails from going out, even if somehow you accidentally screw up and loop over all of the customer emails. None of them will send out. Does that make sense? So we're actually modifying we're changing what the functionality of this class is from outside of the story, right? Very, very powerful and really, really cool. So let's say we put this all together. We build our email class. We build our invalid email observer. We build our limited domain observer, and then we attach both of those listeners to the emailer, right? So now when we send the email, or when we tell it to send the email, it's going to go and say, is it valid? And then it's going to call each one of those. And if either one of those says that it's not valid to send, it will disable sending and we won't actually send the email. We didn't have to modify our sending class. We could easily add additional observers to do whatever it is we wanted to and augment the functionality of our objects and our classes without having to change our original sender at all. This is extraordinarily powerful and very, very cool. Any questions on that? All right.
So it uses both an observer and a subject?
Yeah, you've got your observers are these, and your subject is this. So your subject has a way for these listeners to kind of register, or these observers to register and say, I'm interested in something you're doing, right? Whenever you do a thing, tell me about it. Yep. You've got the subject, and then you've got the observers that are the ones that care about what's happening on the subject. All right, so the next concept is an object-oriented concept called loose coupling. And this is a very important one for building object-oriented code in a way that's easy to maintain. What we try to do is minimize the number of hard-coded dependencies, right? And there's a number of ways that we can get hard-coded dependencies into our code. Probably they're somewhere in your code, if not everywhere in your code. It makes it hard everywhere. It makes it hard to test. It makes it hard to change things out. So one of the ways that we can get away from hard dependencies is by this by using loose coupling, right? So and dependency injection and inversion of control. So very, very simply, dependency injection is rather than doing something like this, right? We say, here's our emailer. It needs an SMTP adapter, right? And we created this SMTP adapter in there. This is a hard dependency, right? Whenever I whenever I construct an emailer object, I'm also constructing an SMTP adapter, right? Chances are that thing is doing something like looking up configs to a real email server and doing all the rest. But if I change it just slightly, right? So if I take it from here and I say, instead of having this construct that takes nothing, I have a construct that takes an adapter, and I set that adapter in. And then outside of this code, I create the SMTP adapter, and I create the emailer and pass the adapter into it. That's dependency injection. That allows us to do a lot more things. We can now take this SMTP adapter, and we can replace it with something else, a fake one, right? Something that doesn't actually send email, but will do all the things that the SMTP adapter needs to do, or provide all the methods and functionality that it needs without actually sending email, right? If we're in a test environment, if we're building unit tests, we can build one that just acts like it's real, but it's not real at all, right? Does that make sense? How many people are using dependency injection or have heard of it? Cool, that's awesome. All right, high cohesion. This is doing one thing and doing it well. So this goes through everything. It means do one thing and do it well in your methods, in your classes, within your packages and namespaces. Everything that the class does should be related to one goal. Everything that the method does should be related to one goal. If you have to define or describe your class and you have to use the word and, it probably means it's doing too much. The same goes for your methods, your classes, your functions, right? If it's do this thing and do this other thing, you probably ought to break it into a couple of different things. Right? The next concept is called preferring composition over inheritance. Right? So yesterday we talked about inheritance. It's not the, your uncle dies and he leaves you a bunch of money. It's one way to expand the functionality of a class. It's probably not the best way. What we do with preferring composition over inheritance is we build classes with other classes, right? So in the emailer, instead of having the emailer know all about how to do SMTP and how to do everything else, we passed in an SMTP adapter. That's all it did. It knows how to do SMTP. It can't even send email on its own. It doesn't know anything about email addresses or how those are built or how they work. But we could take that SMTP adapter out and we could use some other sort of email adapter in its place, right? And so we can use dependency injection to pass those things in, and we get a lot more power out of all of that than we would by defining everything within a single class, right? Here's the photo credits for all the stuff that I used in there. They're all Creative Commons and whatnot. This is my son dressed as a Wookiee. Not a Wookiee, an Ewok, I apologize. It's Wicket. Do you have any questions? Also, I would definitely appreciate if you would go to the joined in link and rate my talk. And while you're there, if you want to, you can download the slides because they're on there now. That is it.